So here to talk through this Narakabe by Worms of Can called columns, where we see all of these connected island groups that give us, at least in these columns, several blackened cells, and where the two columns connect extra cells. We can start in either of the upper right or lower left corners pretty easily by seeing we've got islands and oceans that are growing out. In this upper right corner, we're going to end up getting a cell that's part of an island. We don't know which one yet. To avoid a 2x2 group, it's got to come out, but we need the oceans to stay connected. This can't be part of the 4 group, so this comes down. These get marked. Notice that this 5 coming all the way to the 8 would grow out to 9 cells. That's too many, so this is actually the conclusion of that 7, which we can know for sure. We can mark these in. And I think the next steps are going to be coalescing the middle by also working through the lower left corner. So let's look at that. Again, ocean cells that have to grow out. This 3 is actually fully pinned. The 9 grows out, but we need a connected ocean cell here. That's now touching this 2 island, touching this 4 island, so these come over. 9 wants to keep growing up, but in doing that, it's going to run into the 6 clue. And so we need to take this as its last cell. So that marks this in. This 4 can't come down for connectivity, so it finishes here. We get an island cell here, island cell here. This has to grow out and joins to the 8. This cell can't join to the 5 because it's 6 away, so it's got to come up and join to one of these groups. It's actually 10 cells away from the 9, so it must be part of the 8. And here's a useful thing to count out, is this is a minimum path of 8. There's no other cells we can take on these extremes to still get these to connect. And once you see you have a minimum path, think about the fact that about these cells, at least one of these has to be an island to not be a 2x2 group. So this must be an island. That takes this over. And so we've got this, these 6 of the 8 total cells of this island well known, with one of these two, some other cells we can shade in. We're now making some cells we can't ever reach. Like we can't reach to this cell because the 8 can't get there and the 4 can't get there. We also can't reach to this cell. So these have to be part of islands. These can be shaded off. We've got to reach, we can't reach to this cell from the 8. Again, it's the last is from here, but this 9 has to take at least one of these 2 cells for no 2x2 at the top. And it has some space to keep coming to the left. So some good thinking in the middle to get this stage of the puzzle. And now we've left ourselves 2 mini challenges, the upper left and lower right, and some different things to think through on each side. In the upper left, ocean gets us to here. This is a forced island by 2x2, but it's not part of that 2 group, so this comes up. It'll help to know that we've got a connectivity constraint in here, at least that the 6 has to come across, but this must be part of the 6. It can't be joining up to the 9, so this cell can be marked in. And this ocean has to come and extend up here. So this group has one more island cell to take, and it's one of these 3 only. This 9 is now the only group left that can touch over to these cells, which will be needed for the 2x2 rule. And it can only reach to this one and not any other, not the other one. So this being part of another minimum path marks this off, this in, this as ocean. We're not getting over to this boundary, and we should recognize that once we mark these cells in that the 9 can't reach, we now have another 2x2 group here which puts this island in, which marks this cell off and this cell off from the minimum path. Now these cells have to be reached by the 9 still. This cell always must be taken. And also by the 6 that we've got to take this cell and not those to avoid a 2x2 and a 2x2. So we've got a connectivity constraint for the last part of this 9, but we've got the upper left corner basically solved. In the lower right, the key moment's going to start from this 2x2 square, which will have to at least take these from the 5, and that's going to have to take at least one more cell to come through. That now sets up a packing constraint between this 8 and this 5, and we should recognize that the 8 can only take as many as 7 cells through this cell, but will have to take this cell. And taking that cell, the 5 will have to come down, and that means this island will have to keep coming this way too. The ocean is not going to be able to extend through and separate this blue, so we can't have this channel work anymore, so we have to take this cell once we mark this cell off, and that completes the 5 island. It gives us this connectivity here. And now says we also need the ocean to come through between this blue and red island for this to work out, and that connectivity constraint will give you the rest of the 5 island pretty quickly. This cell being forced for these oceans staying connected gives us those cells for the 8, and the rest of these cells leaving behind a full space for that island to come in. So maybe a little more straightforward than some of the unusual puzzles we've had earlier this week, but it was a good workout, had some different uses of connectivity, minimum paths, open space is in this corner and trying to solve for 2x2 groups, and compact space in this corner, and where we had to figure out, once we knew connections, how to get this 8 and 5 to work together in a notion between them. So highlighted a lot of good steps, so hopefully you got something from watching this video, and we'll see you again soon.